OK, so hello, KotlinConf. Great city, great conference. I'm very happy to see you all here. It was a great talk by Svetlana, like all Svetlana talks. And it's time to talk a little bit about multi-platform development. But I have a story for you. Is there anyone here who has been in Beijing, capital of China, in the last 2 years? OK, very little people. This city changed a lot. We were there, and we were amazing, especially how they are using their phones. So they were using phones for paying in the shops, for paying between each other. When we were in the hotel, there was a shelf with lots of things and prices, and all you had to do was to take a thing, scan QR code, and that's done. Transaction is done. It's amazing how they are using their phones. They were buying things on the phones. They were riding on the metro back home, buying food for dinner, buying clothes. They are messaging like crazy. They are playing games. Actually, on the Far East, it's a very popular pattern that people don't have their computers. They just have phones, and they are perfectly happy with that. And it makes sense if you think about it. This device is way cheaper than a computer, and it has much more capabilities, and in the same time, it has nearly all things you need your computer for. So you have your phone whenever you go. You can listen to the podcast. You can navigate. You can use it everywhere. You can take photos. And when you look at countries that depend on mobile development strongly, you can feel it that we are far away from using all capabilities of mobile phones. It's still much more to discover. And so looking at that, you might think, well, mobile development is a golden business. It's something to go on. But it's not so easy. My name is Marcin Moskala. I am a trainer, consultant, and author. And as a consultant, I see many companies struggling from the same problem. So on the West, nearly a vast majority of companies and most startups, they start on website. And when you see their mobile products, it's more like an adaptation of their website. You know this in your company probably. And this it's a website oriented, but they still want to harvest native capabilities, native mobile development capabilities, so they end up with 3 separate teams doing nearly the same application in 3 different ways, using 3 different set of tools, 3 different languages, by 3 different people. It's like doing 3 times nearly the same thing. And I don't know how about you, but for me, it sounds like a huge waste of money. And so the naive solution to this problem is to have a framework, and we already have such frameworks, web framework that can be used to make native development. So the most popular one is React Native, and it's a bit native, but not really. If you need something native that is not supported by React Native, you need to implement it natively and make bindings anyway. And also, we are very strongly married to this framework. So if for instance, what's the lifetime of average web library? So are you sure that in next 10 years it will still be used? You will find the developers? But yeah, I think it's hard to make everything, the common parts, same tools, and in the same one language, and have it all natively. Or is it? Actually, we can have it when we use Kotlin. We can use the same language, same tools, have common parts, and have it all fully natively. So we can natively harvest all the capabilities of phones. We can integrate with telephony, with payments, with everything that native application gives us. So let's make a quick recap how it is possible. So Kotlin is a compiled language. It means it's compiled to something else. In the most popular configuration, Kotlin JVM, it is compiled into JVM bytecode. And that's why it is compatible with Java, and that's why it runs on Java virtual machine. Slightly different configuration from the same code. We can have JavaScript generated. And it can run on Node.js or on our website. Slightly different configuration, Kotlin native, and we can have native code generated. So it can run on iOS, it can run on Raspberry Pi, and many, many more. So using these 4 configurations, we can write for all our platforms we need. So the popular choice, and actually this is a standard already, is to use Kotlin JVM in Android. We can use Kotlin native in iOS, Kotlin JS in website, and Kotlin, I mean, basically we can use any of those, but the most popular option is to use Kotlin JVM on backend. And what is even more important, that we can have a common parts, so common modules that are compiled to any of those languages. And these common modules can include platform-specific codes thanks to expected declarations. They're like empty declarations that needs to be filled for each platform. So this is one way, and this is the most popular way. But there is also the other one I would like to mention. So basically, you can use Kotlin native in all of these devices, since they're all having a processor, and on web we can use WebAssembly. So this is another approach, and they are both reasonable for different cases. For instance, using Kotlin native everywhere is a very reasonable to make high-performance application, multi-platform application, or to make, I don't know, game engine. But it's very hard to make normal applications this way. Just imagine writing your application in C or C++. So yeah, for what we are going to talk about, the standard way of that is to use the platform-specific languages for each platform. OK, so we have all the tools, and we can start talk about the extraction. And let's start from the simplest level of extraction. So when you look at all your clients and backend, you can find some elements that are the same or nearly the same for all of them. And the simplest one is a data model. But this one is actually a bit tricky, because should we extract data model? And this deserves another presentation, but the simple answer is that it depends how do we treat our data model. So if we treat data model as the way we pass data between our layers, between our objects, then we should rather not extract it. Some architectures even suggest to use different data model for communication between different layers. But if we treat data model as how we see the world, as abstraction, as something above implementation, then it's totally fine. It's very reasonable to extract it. So choose your poison. It all depends on your decision. What we can extract for sure is an API DTO. So how we represent our API. It's the same for all the clients and for backend. We can always extract it for sure. And what we can also easily extract is a set of utils. So small objects, functions, something that is not our application specific, but more general. But in most applications, we don't really have a lot of utils. And the reason behind it is that they are already extracted into libraries. So most libraries are nothing else but a big set of utils. And based on this idea, you can imagine that a lot of libraries might have a structure that looks a bit like that, a structure where vast majority of this library can be extracted into a common module, and only a small part needs to be there to provide platform-specific elements. And if we base on this idea, you can imagine that if the platform-specific part is pretty small, you can add easily JS and native parts and have this library available for way more languages. So of course, it's not for all libraries, but when you read libraries, you can find a lot of libraries that have this kind of structure. So based on this idea, I have a library creator master plan. The first step is to migrate your library to Kotlin. If you are here on KotlinConf, I assume that if you are a library creator, it's already in Kotlin, so you can skip this step. Kotlin is a good library. I think it's a nice thing to do. Then move whatever possible into common module, and be surprised that nearly everything can be moved into common module. Very little thing needs to be left in the platform modules. Write platform modules for other platforms, and you can announce that your library is now available for way more languages. So if it was Java library, right now you can use it on JavaScript, TypeScript, on CoffeeScript, C, C++, Python, since it can use C, Swift, etc. So for many libraries, it might be quite a quick win for a big improvement. And also, your library will be available for Kotlin multi-platform project, and it will join a club of very good libraries that are already available for multi-platform development, including Kotlin standard library, which has exactly this architecture. Ktor client, which is a very nice library for network operations you can use in common modules. Data to this. Mock, that is right now only on JS and JVM, but I hope it will be on native as well, and many other libraries. OK, what might be problematic during this process? Well, the biggest problem, from my experience, is always third-party libraries. So if they don't have their other platforms equivalents, they are always problematic. But if you are doing library, you should avoid third-party libraries anyway. So probably it's a good motivator to get rid of them. Another platform-specific thing is the date and time, but it was already shown many times how you can work with that, and there are libraries, so it's actually pretty simple. Reflection, you can use Kotlin reflection. I/O is platform-specific. There are libraries for that. Serialization, there are libraries for that. Generally, for common cases, there are already common libraries, so you can replace platform libraries with common libraries. The big problem are third-party libraries that don't have their common equivalents yet. So at this moment, you might think, well, if extracting an abstraction into common modules is so easy, why can't we just make a DSL for making views in Android and DSL for making views in iOS, and extracting DSL itself into common module, and so we will be able to write both Android and iOS in a common modules together. And if we would need something platform-specific, we should be still able to write it in the platform-specific way. So yeah, basically, it's possible, and it would make us very happy. But what we don't want is another library that forces you to write everything in a common parts, and if you want something platform-specific, make bindings to Android and iOS. And at least till now, all the libraries strive into this architecture. If this is the architecture you want to achieve, my recommendation is to use React Native. And if your argument is, yeah, but I want to use Kotlin, then my recommendation is to use Kotlin.js. So yeah, this is exactly what we could have that already. If what would be really nice to have is a library we can use for making a mock-up or minimal valuable projects for quick development, for quickly making our application in common module. And then when our application grows, we will be able to slowly move it more and more into platform-specific ways, in the solid and well-tested platform-specific ways. But yeah, let's talk about the most important part of this presentation, about logic abstraction. And I would like to ask you, do you know this book? It's a Polish translation, but it's a Clean Architecture by Uncle Bob. So this book has many great concepts, and I think the key of this concept, the most important concept, is that the most important part of our application is its logic, so how it behaves. Everything else is kind of a detail. What database do you use? What is the network communication? Of course, it still requires a lot of work, but the most important part of our application is a logic. And there are many architectures, including clean architecture, that supports this approach and this vision. I could present clean architecture, but let's just work on the simplified version that is a MVP. So the argument is basically the same on the clean architecture. There are a few additional elements, but it's basically the same architecture. And the key idea is that we extract logic into so-called presenters or presenters and use cases. And they should represent how our application acts, what is interested from the behavior point of view, from the business point of view. This is the part that should be unit tested, and it should not depend perfectly on no libraries. It should definitely not depend on any databases, on any network communication. We have views that represent presentation logic, how application looks like. So views are in separate layer. And presenters manipulate views to display things or to do other things. And we have repositories that represent communication with other components, so with network, with database, with preferences, etc., etc. The key part is that presenters should not depend on repositories or views. So repositories and views should be hidden behind interfaces. And so in the real implementation, we need an interfaces for views and repositories. Sometimes they add interfaces for presenters, but it's not really required. And we always have some data model and utils with the objects we operate on and objects we use. And this architecture can be applied in all clients. So you can find it on Android, iOS, web, desktop, etc., etc. Plugin, Chrome plugin if you write it, I don't know. And we have something to work on. So the first and easiest step of extraction is to extract data model or API DTOs and utils. We already discussed that. But another thing we can extract is a set of our presenters together with repositories in interfaces. We can extract them because in most cases, they are not platform specific. They represent logic, and this logic, in most cases, is the same for Android, iOS, and web. Sometimes it's the same only for Android and iOS, but if it is the same, it can be extracted, and it should never depend on views and repositories anyway, so it can just go and be extracted. In practice, we have many good libraries for common modules, so things like network communication, database communication, even preference communication can be implemented in common modules. So from my practice, most repositories can be extracted into common module as well. Interfaces for repositories should still be there. It's a simplification. So on the end, we can have this nice architecture where nearly everything is in common client. I separated common client and common because backend depends only on common, but some people merge them. So nearly everything is in a common module, and only view declarations are in platform modules. So the platform really decides only how the application looks like. Sometimes if we need something platform-specific, we'll make repositories for that on these platforms. If, let's say, we need some communication with telephony manager in Android, we can make a repository for that, interface in common client, some empty interfaces on iOS on web, or just nulls to say that for these platforms there is no such thing, and we can still use platform-specific elements. And the big idea is that the logic right now does not need to be written 3 times. It can be written once and reused for all these clients. But at this point, it's important to mention a very important relationship between redundancy and coupling. So when we extract something and reuse it for many clients, we remove redundancy, but we introduce coupling. And the answer to this problem is also in Uncle Bob's books. And in general, it's a dependency inversion principle. So in general, the elements that are upsides in the presenters in this case, or a data model in previous case, should not depend on implementation, should never depend on implementation. It should depend on abstraction, in how it should look like. It should never change to adjust to views. the views needs to adjust to presenters. I know it's an abstract answer, and you cannot always do like that, so this is like an ideal we are striving to. But the general idea is that if you treat presenters as a logic, as an implementation of logic that is never dependent on our implementation, it's generally fine. So yeah, so on the end, we end up with this simplified architecture when we have a common module we use on all clients and backend, common client module that can be used by all clients. In practice, we can move it to two ways. To one way to extract common modules for common parts, so common platform-specific declarations for common can be in separate modules. Platform-specific declaration for common client can be in separate modules as well. It makes a lot of empty or nearly empty modules, but the profit is that on the end you can reuse it for way more clients. But you can also go in the other way, and from this architecture, do not extract separate common client, just put everything in common, and this architecture can be also found on open source projects, including KotlinConf project. I will talk about it a bit later. So yeah, this is a big idea. But before I will talk about an example, I want to mention one more architecture I think many people wait about. It's MVVM. And MVVM is basically an evolution of MVP. And many people wait about it because it's popular in Android, it's popular in iOS, and it's also a key architecture in Xamarin, the platform that tried to do multi-platform native development already. And it looks like it works very well for them. And the big idea is kind of an evolution of MVP. So instead of presenter, instead of modifying view by using interface, it creates its own fields and it changes its own fields. And views binds to these fields. So when presenter changes its own fields, view is changing itself. So it's very nice. It's easier to unit test. It's generally easier, less boilerplate code. It's also the nice part is that if you introduce new feature, you don't need to immediately add it on all clients to make it work. You can just make new property and add bindings for other platforms later. So in general, it's a very nice approach, and I am waiting for that. But I don't know any library for that yet. I hope someone will do this. It's totally possible. It's supported in iOS, supported on Android. We can bind to fields on React. And if we use Angular, it's also a pretty native library for Angular. So if we use Angular instead of React on frontend, so we have native architecture for all the clients. So it will be very nice. But as I said, we are waiting for some hero to make a great library. So let's get to some examples. A simple example, and this example is available on GitHub. So since this link might be useful for you, I decided to bring it here and leave it on the bottom so you can use it in the future. Though I must warn you that we are changing Gradle plugins right now. There was old plugins, Conan, then we have new plugins, and right now we move into multi-platform plugins. It will take a few days to adjust, but yeah, code will not change, and I think it shows the idea. So we are going to build a quotations. Wait, it's not run. Okay, quotations applications for Android, web, and iOS. It's a very simple application just for presentation purposes. And what do we need for this application? We surely need some data model. And for our data model, all we need is a quotation. So we need some quote. We represent it by text and person. We somehow need to represent a view. So the abstraction for Vue will be just an object that shows a quote. That's all we need from Vue. From the presenter perspective, Vue is just an object that presents quote. And we need to represent a quotation repository. So under this repository might be everything. It might be API, it might be database. In this case, it will be a little bit easier. So our presenter can be very simple as well. So it holds a state. Generally, presenters supposed to hold the state, except of caching and other repositories parts. It has on start that calls on next, and in on next it just bumps an ID of quote, gets this quote from repository and displays it on a view. A very simple thing. Though just because it's simple, it doesn't mean we should skip unit testing. So I also wrote unit tests, and unit tests are using a mocking library that is available in multi-platform projects, in common modules. It's called mock, and it's a really nice library by Alex Plenko. Great job, by the way. So yeah, you can use mocking library in a common modules. Our repository does not need to be hard. It's just a list of quotes, and it gives how many quotes do we have, and gets quote by ID. In Android, we have a concept of activities. So activity is like a window. So when activity starts, it calls on create. On all create, we use our presenter on start. So we indicate that our view started. And once the button is clicked, we call presenter on next. We also need to implement view. So our activity implements quotation view. And so it needs to give show quote and show quotes on view for once this method is called. So let's see how does it work. Okay, it works. In general, I believe most of you are Android developers, and you should be familiar with that. All I need to tell you is that when you modify common modules, it's exactly like modifying any other part on your code. So it's just working great. You can change something in common module and just run it. It runs like if you were changing any other part of your application. Okay. This is our web client. It's written in React. In React, we have a concept of components. So components are part of views. In this case, it's a whole view. And they also have their own life cycle. So when component mounts, the component did mount is called, and we call presenter on start. When show quote is called, we change the state. Every component holds some state, and whenever state is changed, render function is called, and this render function builds our HTML. So you can see HTML DSL over there. And so whenever new quote is displayed, render is called, new DSL is displayed, so we have new quote displayed. So let's see it in action. So you can make a task in IntelliJ. I prefer Gradle. You have address, localhost. You can start it, and it runs. If you make any changes in some common module, notice that you can jump into common modules and modify it the same way. Right now we have one IDE for all clients, as Andre already announced, so we can write everything on IntelliJ or on Android Studio. So we don't need any other platforms for that. And you can see that changes are applied. So we changed on common module that we should have text in uppercase, and it works fine. Okay, let's get into iOS. And in iOS, we have concept of controllers, which is very similar to concept of activities in Android. And when a component is load, then we have viewed it load, so we call presenter on start. We also need to implement some interface, and we show quote. Though right now there is a problem with Kotlin native. it has problem with mixing Objective-C and Kotlin interfaces, so I moved it into object expression. And by highlighting that, I wanted to show you that iOS development in Kotlin is far from being perfect. But I will show you a nicer approach in a second. So let's see it running on the project. You can run it on Appcode. And it works on iOS. So yeah, but I believe that moving projects from Swift into Kotlin is not only hard, but also a bit absurdish. And what is even harder is to move iOS developers from Swift into Kotlin, especially since Swift is actually quite a nice language. And the good news is that we don't have to do it. And actually, I believe it's better to leave iOS development in Swift, and we don't need to resign from multi-platform architecture by doing that. So we can have everything written in Kotlin with one exception, iOS written in Swift. So in this architecture, Common Client Native builds a iOS framework, and these frameworks can be used on Swift. So this is how it looks like. This is the same controller written in Swift. There is no problems in here. We have our bindings. We use our presenter. We call on start on view.did-load. We call on next on when next button is clicked, and we show quote. And this is especially important video because I wanted to show you how well it works. So at first I built it just like that, and then I apply some changes. So I deleted some code, and I deleted this code to be able to show you that you have hints, and this library that is written in Kotlin and compiled into Objective-C framework acts like library written in Objective-C. And you have very well mapping. So if you have Kotlin property, you don't have setter and getters like in Java. You have Swift property. You have all the features are preserved, and it works really, really well. So I think this is the coolest part of today's presentation, that we can make Objective-C framework from Kotlin code, use it, and it works very well. And I think it's a very cool approach. In theory, we might make the same approach in JavaScript, and I wanted to show it to you. So all we need to do is to set up to produce pure JavaScript code, and we can use it in HTML. Simple. It's only, wait, what is that? Well, it's the problem with interoperability between Kotlin and JavaScript. Well, JavaScript is a dynamic language, and so there is no such thing as function overloading in JavaScript. And to prevent this problem, there is this weird hash after show quote. It technically can be fixed. So to fix it, we need to make expected declaration, empty expected declaration for annotation in common module, and fill it with JS name annotations in JS modules where this annotation exists. And in other modules, we need some empty annotation. And once we have this annotation, we can use it in common module. So when it compiles into JavaScript, it is translated into JS name annotation, so it enforces compiler to use this name we provided. So on the end, we can use this show quote function. But what I wanted to show you by this example is something that I already seen in other places. That the point is that, from my experience, using Kotlin from Swift is great. It really works well. But using Kotlin from JavaScript, it's sometimes tricky. I mean, all the problems can be overcome, but it's sometimes tricky. On the other way, it works very well. Using JavaScript for Kotlin works very well. But using Kotlin from JavaScript, not always. So I do demos for everything. This is just an HTML, so we can just open the website. And then we can apply some change. It doesn't run. OK. OK, open this in website. Then we can apply some changes like everywhere else in common module. And all we need to do is to rebuild our application after that. So yeah, I rebuilt application in Gradle. It works fast. And I heard it's even faster right now with this multi-platform plugin. And it works well. So it's possible, but sometimes tricky. Yeah, so I think the most important takeaway is to notice that using Kotlin from Swift is very nice, and so you can have a common parts for Android and iOS, which are normally the most similar parts. And this is something that already can be used on many, many companies. Of course, I know that it sounds like crazy, like extracting everything into presenters and things, but you can just start from a baby step. You can just make a single presenter, single repository, make a hackathon, use, and I don't know, 1 or 2 days, and use it for Android and iOS. And I'm sure that you are going to be amazed how much time do you save from the fact that you don't need to write it twice. So the cost of trying it is actually very small, and the potential profit is quite big. So you can just from this, you can achieve 2 times faster logic development, unit testing, because logic is what is the most important parts that needs to be tested. 2 times faster API development. You don't need to make different API for Android and iOS. I mean, different API client for API and iOS. You can use Ktor client and have it for both together. And you can have consistency between platforms. So if you know that something works this way in Android, you are quite sure it works the same way in iOS, what is also sometimes an issue in companies. You can go even further, what is obviously a very good thing, but it is not an easy step. This is a long-term step. You can go further and also write a web, but I think it's better if it's written in Kotlin. Kotlin for JavaScript works very well. So if this is a new project or if this is your side project, I think it's a very nice approach to try to reuse presenters for iOS, web, and Android. And also you can reuse some parts with backend. So yeah, if you look for some examples, the #1 example is KotlinConf application. You can check it out. It's live, and it uses exactly this application. So iOS is written in Swift, but it uses common parts that are written in Kotlin. And yeah, a lot of things are written in Kotlin over there. It was a bit more complex because there were some codes, but later we stayed with a bit simpler application. But it's a good example. For a bigger application, for a bigger example, you have a Code Academy portal. It might be familiar for some of you. It's bigger application. It shows a different kind of newses, puzzlers, articles. You can provide your own. You can submit your own newses or puzzlers. And this is also a multi-platform application. It was mainly written as an example how you can make multi-platform project. So this is another place you can check out how it can work for you. So let's make a short summary. So the first big point is that many libraries can be migrated into multi-platform, and thanks to that, achieve support for many more languages. Also, view declarations can be moved into multi-platform. We need a library for that, but it's totally possible. The big architecture that is like a master plan for a long term is an architecture that uses Kotlin in all clients and Swift in iOS. And we can reuse things for backend, and all clients are just for clients. And MVVM, many people ask me about it, so I answer it right now. It's possible, but we are waiting for some good library for that. Here are links for all the images I've used, and it's time for your questions. Thank you for your attention. There is a microphone lady who is coming to you. Oh.
I guess I won. OK, I got a question. What kind of black magic did you do to get Swift to import the actual Kotlin code that compiled down to, was it Objective-C code, or was it native Swift code?
No, it's actually, the point is that we configure, in Gradle, we configure this Kotlin native plugin, this Kotlin native configuration to build Objective-C framework. So all I did in the Xcode is a simple script that first calls build this module, just to be sure, and second copy it and link it to our project. So I haven't written an article about that, but there are already few articles how to do it, and there are many examples. And the Swift is used in KotlinConf application, in Code Academy application. So you can see many examples.
On those GitHubs, it would have
yes.
that? Okay,
the most important part you need is to open iOS module in Xcode, go into configuration, and check out build phases.
Yep.
And you will see the custom shell phase that builds it and copies the file. And there is also a link with that. Awesome. So yeah, that's it. Simple.
Hi. Wouldn't it be more efficient to use WebAssembly, Kotlin native and WebAssembly to handle the browser side? All modern browsers support WebAssembly. It seems much more efficient than doing transpiling to JavaScript.
Yeah, so in long term, yes. I wanted to make a practical speech, and I haven't seen any application written like that. I think in long term, it's a better idea to use WebAssembly.
Hello. I just another question. In your example, your repository is synchronous. It returns a quote, which is synchronous. In Realistic code base, we expect to be a call to an API. So, of course, it could be a coroutine. And theoretically, it should work. But last time I tried to do that, coroutine support was partial on iOS. We didn't have any common HTTP library. And the tooling was very...
I know what you mean. Check out KotlinConf application. We use coroutines. And iOS is a bit tricky because I think it's still not, at least when we did it, and it was like 2 weeks ago, it was not supported for iOS. But we made kind of a hack, so we made our own dispatcher that dispatches into UI thread in iOS, so we made it work. The solution is pretty simple, but it's not officially supported yet.
Do you have any idea when it will be?
I mean, it works. I mean, I think the coroutines are there to stay, and I think it's a good idea to use coroutines in presenters. I have very good experience with them. And about using them in iOS, check out KotlinConf application. It works really nice.
OK, thank you.
Yeah, thanks for the presentation. So should we start using it in production, and how far we are from stable release? Or?
Yeah, so there were just released a new plugin that I understand supposed to be the final multi-platform plugin that unifies how we configure all these platforms, including common modules. and I understand it's a thing to use on production. Yeah. And about whole approach, I mean, my recommendation is, as always, there are many different projects. They are very, very different. There is no one solution for all projects. So I think it's a very good solution for a lot of projects, and I just think you should try it. You should check out all the advantages because they are awesome, and you should discuss it with your team.
So you mentioned that you are waiting for a proper MVM framework. Can you elaborate a bit more what you expect from that framework to do?
I think I had a slide for that, but I think it's hidden. OK, so this is my improvised solution, how it might look like. Yeah, so the point is that you need some properties to hold a state in presenter. And you set these properties. There should be, of course, dot, not a slash. And you set these properties whenever you want to change something on the view. And the view is bound to these properties. So whenever we need, whenever these properties change, our view changes as well. So of course, in Android iOS, we have bindings on layouts. So it's simple. It might be a bit more tricky in React, but it might be done by binding the property to property of state. So then, whenever the properties change, state is changed. So we re-render, and we have change on our view.
So I've worked in Xamarin before, and debugging problems and memory leaks was a total nightmare. What's the story with debugging in Android Studio and Multiplatform?
I had good experience. I normally use debugging in common modules when I did Android development. It's a bit more tricky when you do iOS development. I hope it will be supported, but right now, we rather invoke this use case in Android, and you can debug it when you run Android. Is that it? OK, so thank you.